we have this solution of ammonia, and we want to know the pH of the OH. Now, tricky thing with this is we're not given the pKa or the pKb value of the ammonia. We're given the pKa, which is the conjugate, the pKa value of ammonia's conjugate acid. All right. So we need an equation, right? So ammonia plus water when it acts as a base, bases take protons, so it becomes NH4 plus OH negative. So base acid. And we're given the pKa value of NH4 plus is equal to 9.3. All right. So to solve for this solution, we've got to use this and you turn that into a pKb value or a Kb value eventually. So pKa, and these should be capital Ks. Kb is equal to 14. So pKb is equal to 14 minus 9.3. So that's going to be 4.7. pKb is 4.7. I just checked it on a calculator to make it right. Now, pKb is equal to the natural log of your Kb. So, the negative log. So, to get Kb, I take 10, and I'm going to get my Kb is equal to 10 raised to the negative 4.7. That would give me my Kb value. So there it is on the calculator, all right? A little bit hard to see, it's getting kind of dark. So my Kb is equal to 1.99 e to the negative fifth, all right? Now that I know my Kb value, I can set up my Rice table and use my equilibrium equation, all right? So here's my Rice table, okay? Now I know I had 0.1 of this. That doesn't matter, 0 and 0. Minus x, 1 minus x plus x plus x. All right. Now some people like to use different letters for the variables there. I like to just use x. I think it's just simpler than having to remember a different letter for each equation. Anyways, now going to use my Kb equation. All right. And Kb is going to be, according to my equation, is going to be my concentration of ammonia under my concentration of ammonium. All right. And I got Kb, where was it? There's my Kb value, 1.99 e to the negative fifth. All right. So 1.99 e to the negative fifth equals 0.1 minus x times x. All right. Here I'm going to neglect the x, otherwise I can't, well, not that I can't, but AP is not going to have you do those kinds of equations. So I multiply both sides by x. I get 1.99 e to the negative sixth equals x squared. All right. Now I'm going to take the square root. So it's 2, roughly 2. All right. My number is still there. All right. So times 0.1, enter seconds. Oops. There I got 1.4125. So x is equal to 141 e to the negative third. All right. And this is my concentration of hydroxide. That was one of the things I needed to know, but I want to know pH. Now you have a couple options. I can turn this using Kw into concentration of hydronium. I can take the pOH and do it that way. I'm going to do the pOH. The pOH is equal to the negative log of the concentration of OH, negative. So negative log of second answer, I get 2.85. So my pOH is equal to 285. Then my pOH plus my pH equals 14. So I would do 14 minus 14, and I get a negative. All right, but I just minus 14 instead of flipping around. So I get my pH is 11.15. There it is. pH is 1.15. All right. Now, how many sig figs do I need? I had a 0.1 molar solution, so I really should only have one sig fig. So this would be point. I think I rounded this 0.11, 11.12. All right. I think, and I should have two sig figs. Sorry, I miswrote. It should be 11. When I wrote down 0.1, but it was actually, oh, look, there it is. 0.0001. So I should have three sig figs. So I lost one. So that means, what do? I add a 0. All right, because these count and those don't. All right. So my answer is this. Now, the book did the same problem. That's where I got it. And you'll notice they got this. That's because they didn't neglect the x and they solved it using a quadratic. All right. Oh, they look, you actually 0.1, you can just do a perfect square. All right, they did that. But they, x is small. Why did I get a different number? I'm going to pause this. Okay, I figured out what was different. I used, when I started with my pKa value of 9.3, I got that off the internet. And the book gives a pKa value of 9.25. So that's like a 0.75 difference. So their KB value was a little bit different than mine. But it's the same process on how you would do it. All right? And that's how you do it. Okay, hope you have a good night. Bye.